Hmm. So hello everyone, I'm Mahima Agarwal and I'm currently in my last year of BTech CSC at SRM University UP. In this video, I will be explaining a really interesting topic, which is hybrid search, which combines BM25 and Vector Embedding. So you will often hear these techniques in the modern search engines, AI systems, and chatbots. So understanding it, this will be quite useful. And in the next few minutes, I'll walk you through what hybrid search is and why it is needed. So first of all, what exactly hybrid search is? Well, hybrid search is a combination of the traditional keywords, which are based for lexical retrieval in modern context based known as semantic meaning. Combining of these both will give that as hybrid search and understanding the semantic meaning search using vector embedding system identifier concept related content and including recall and contextual understanding. It also gets a bridge between the semantic gap. Hybrid search combines the strength of both approaches and overcome the challenges like vocabulary mismatch, contains ambiguity, and missing semantic relations. So the motivation for this, so why do we need hybrid search? This is a way, think of it as a way like BM is excellent at handling the exact word keywords, but it fails in using synonyms and paraphrases. On the other hand, embedding captures meaning, but it sometimes doesn't match the exact terms. So by combining this, we can get the vocabulary mismatch. We can handle the vocabulary mismatch and context ambiguity. In short, game papers bring precision, ambiguity, and embedding brings understanding, and together they give us the best results. So, what are the core concepts? There are two main components, which are BM25 and vector embedding. BM25 is a ranking function used in search engines and calculate the relevant score based on the term frequency on how the word appears. Inverse document how rare the word is in document length. So this is a formula for BM25. And semantic vector search, which represent the queries in documents, extends vectors in semantic space, measuring similarity using cosine similarity, and this is the cosine similarity formula. Hybrid search consists of both lexical search and semantic search, which are combined to prove the robust retrieval. So, what is the architecture of the hybrid search? So, the first is query processing. The text query is processed for both BM2 and vector embedding. Then it comes to parallel retrieval. The BM2 model retrieves documents based on keywords overlap, while embedding model retrieves based on semantic similarity and fusion or combination. The scores or ranks from the BM25 embedding models are merged using a hybrid score formula to provide final results. So the hybrid score gives a formula in the center of square image with black spots where alpha is a weight balancing the lexical and semantic score between 0 to 1. Similarity is a percent similarity between the document embedding and interpretation. When alpha is 0.7, it prioritizes BM25, which are keyword heavy queries, is alpha is 0.3, it prioritizes embedding, which is semantic queries. So this is the formula. So now let's come to our example. So let's take a simple example to understand this better. Suppose we have three documents, B1, AI is the teaching system, B2, artificial intelligence research, and B3 is education technology and MA. Now assume we have a query, AI in education. So BM25 embedding model give us in document 1, BM25 score will be 1.2 and percent similarity will be 0.80. For document 2, BM25 score will be 1.4 and cosine similarity will be 0.60. In document 3, the empirical score will be 0.80 and cosine similarity will be 0.90. So if we set and we calculate the score for each document, we'll see one rank higher. This way, even if the word doesn't match exactly, the meaning still is captured. So what are the advantages of hybrid search? So it gives a balanced retrieval combining the exactness and the meaning. It improves coverage, handles synonyms, context, and rephrasal queries to ensure broader retrieval. Third, it is noise resilient, performs well even if one retrieval system fails. Scalable, work efficiently with modern vector database for large-scale search engine application. Fifth is customizable. Weights can be turned per use the case to balance the keyword's relevance semantic meaning. So hybrid search is just not theoretical, it is also used everywhere. Like in search engines, it combines a keyword and relevance and meaning. In e-commerce, match product title and similar description. And in customer support, retrieval of facts and cues by intent, academic search. Find conceptual related papers in chatbots and QA system match user query question semantically. So of course there are challenges too. So the first is a weight tuning, choosing the best weight for each data set can be tricky. There is an index maintenance. We need to maintain both inverted index for BM25 and vector index for embedding. Latency can increase slightly since two retrieval happens in parallel. And finally, demanding drift where embedding might relate unrelated concepts, but even this limitation, hybrid search engines are top performing real world solution. So current research is in the field is it is still evolving fast, and we have some models like CoIBOT and CoIBOT V2 used as advanced late interaction techniques by hybrid retrieval. Platform like OpenSearch and Pesca already support hybrid retrieval natively. Researchers also experiment using re-ranking where BERT models designs the results by hybrid scoring and uh, hybrid hybrid scoring after and that's where the and all of these innovations are making systems even smarter and faster. So to wrap it up, hybrid search merges the precision of BM25 and intelligence of vector embedding. It handles both what we say and what we mean, and that is why it becoming the foundation of modern intelligent search system, from Google to Bing to specialized tools in research and e-commerce. So in short, hybrid search isn't just an improvement in the future of information retrieval. Thank you so much for watching.